Okay, now we're going to be taking a look at how to figure out if something is going to be a solid, aqueous solution, or a gas, or anything like that with predicting solubility. All we have to do is keep in mind some basic rules. All common salts of group 1, so if you look above your periodic table, you'll see group 1 elements and column 17, or also ammonium ion with a column 17 element. That's going to be soluble. Another one is going to be acetates and nitrates. Every single one of those is soluble. Binary compounds with metals are soluble except for, and this is where you just want to take a look, silver, mercury 1, and lead. Sulfates are soluble, and we just have some exceptions. And then, except for those in Rule A, carbonates, hydroxides, oxides, sulfides, not sulfates, sulfides, and phosphates are insoluble. So we would put an S after that. So let's take a look at some examples here. We have, let me just pull all of them up. If I look at Rule 3, we have a sulfate. So barium sulfate, all sulfates are soluble. I just have to double check. Oh, there's the exception, barium. So that is going to be a solid. We look at the second one. We have nitrate, lead 2 nitrate. And we look at our nitrates. All nitrates, Rule 2, nitrates and acetates are soluble. So that would be lead nitrate, lead 2 nitrate would be soluble. Ammonium sulfide. Sulfides are insoluble except for those in Rule 1. Well, in Rule 1, we see ammonium is being listed as soluble. So that one would trump the Rule 5. So according to Rule 1, that's going to work. Calcium sulfide. Calcium, basically just kind of keep going with these examples and see what works. Now, let's see what we do with those. Here's what we will be using with solubility rules. It is used to predict if something's going to be a solid or an aqueous solution, but we'll also use them in terms of net ionic equations. Net ionic equations, first of all, the first step is to figure out what is aqueous and what is not. And then we're going to split up everything that is aqueous into its respective ions. Everything that is not aqueous stays together. Then we're going to eliminate those redundant ones. We call those spectator ions. We're going to cancel those out and then basically condense down. We'll balance according to charge on both sides and then balance according to elements. So basically a net ionic equation is saying, okay, all the other garbage aside, what are the essential things to make this solid or gas or whatever the point is? Let's take a look at an example of how we'd use this. Okay, we're given in the example of lead plus silver nitrate yields silver plus lead 2 nitrate. So basically we're going to turn lead into silver. So what we want to do is, in this problem it's already been identified what our aqueous solutions are. Because of the nitrate rule, all nitrates are soluble, Rule 2. A silver nitrate would be soluble, as would lead 2 nitrate. Silver, if I look on my periodic table, I would see that that's dark, so that's going to be a solid. Lead is going to be a solid. Now the next step, what we're going to do is we're going to rewrite everything, and I'm just going to split up or dissociate my ions that are in an aqueous state. So I'm going to split this up. Now, a silver plus 1, that's aqueous, plus a nitrate that's an NO3 with a -1 charge. That's aqueous. That's going to do a single replacement reaction and form silver, the solid, plus lead, the +2 ion in an aqueous state, plus nitrate, NO3 with a -1. That's in an aqueous state. Okay. Step 2, I want to eliminate my spectator ions. It must be the same state on both sides. So here I see silver with a -1 charge is the same on both sides. Lead is over on this side, but it's a solid, and over here it's an ion. Now, I'm going to rewrite these, and that's going to be lead as a solid, plus the silver ion, that's an aqueous solution, and that's going to make silver, that's a solid, plus the lead 2 ion, that's aqueous. Okay, so now we need to balance both sides. If we have lead on one side as a solid, that's a 0 charge. Silver is a 0 charge. So on the reactant side, overall, I have a +1 charge. On the product side, overall, I have a +2 charge. So what we need to do with that is we need to balance. Both sides need to have the same charge. So I'm going to put a 2 in front of my silver to balance those charges. Now if I take a look, I have 2 silvers, and I need 2 silvers on this side. On the reactant side, I have 1 lead and 1 lead on the product side, 2 silvers on the reactant side, 2 silvers on the product side. So that's how you do a balanced equation for net ionic. Make sure you put a box around your final answer so you can see how that goes, and basically just follow the steps. You eliminated spectator ions, and you're done.